Team is Mr. Z, and today we're going to continue to look at transformations and how they affect our new inverse function, the radical. Let's take a closer look. All right, so essentially what's going on is this chart is review of all of the transformation rules. You can see up here at the top, this is going to be the key format for any type of function. We've been talking about various types. We've gone from rational. Now we're talking about the radicals, which include the roots. So some of the same rules are the same. Then a number is out in the outside. It's going to deal with a vertical stretch or compression. If it's multiplying the x, it's going to be a horizontal compression or stretch. If it is next to the x and being added and subtracted, it's going to be a horizontal shift. And if it's on the outside like d is, it's going to be a shift up and down. The other thing to keep in mind is, remember, rewrite your equations in the form of minus in order to guide your intuition. Because if I look at this, the square root of x plus 3, this means left 3. Why does it mean left 3? Because if you view it as x minus a negative 3, which is equivalent to plus 3, you can easily see, oh, it's minus 3, left 3. All right, let's go ahead and do some examples. I would have this information that's in the chart on a note card of some sort. You can have 4 note cards, 1 for each letter. So looking at this, we need to consider the function f of x is equal to the third root radical x, the cube root. Describe the combination of transformations you can do to obtain the function g of x equals 1/6. Well, 1/6 is in the front, right? 1/6 is my a. My a is going to be equal to 1/6. What does that mean? Well, it's a fraction, so it's going to be a vertical compression. B. Is there a number being multiplied by the x? Yeah. Now, B is going to be, there's a negative in front of it, -1. This is going to mean that is a reflection. And it's going to be a reflection across the y-axis. I see my c value is equal to -5. Now I'm going to back up. It's actually just going to be 5. Notice here, it's x minus, well, I see a 5. That means it is going to be a shift to the right. And then finally, my last piece of information is 7. D is equal to 7. And this means it's going to be a shift up 7 units. All in all, each piece of information communicates something different, and it's up to us to recognize and be able to identify them. Number 2 is going to be very similar. Notice how the number in front is a negative. A is equal to -1, and this is going to imply a reflection across the x-axis. I look for B. B is equal to 1/5. Now, because it is the B value, it's actually going to be a horizontal stretch. Consult your chart. C. Now, some of you might say it's -8. but C is always going to be x minus C. Notice how it's inside of the radical. So here, C is equal to 0. There's no change. And then D is equal to negative A, which is a shift down 8 units. Number 3. Oh, the number in front, A, is equal to 4. This is going to be a vertical stretch. It's going to get bigger. B, there's no number in front. It's just going to be 1. No change. No effect. Now, this is where I'm going to reimagine it. I'm going to rewrite it as x minus 3. C is going to be negative 3, and this is going to mean it's going to go left 3. D is equal to 9, so it's going to go up 9. Consider this function. What happens? Well, there's no number in front. Well, that just means the number in front's 1. It does not have an impact. My B value is equal to 5, and this is going to actually be a horizontal compression. Notice again how in the radical, some of you might say C is negative 2, but it's always going to be x minus the number here, x minus 2. This is not what it looks like. So here, my C value is going to be 0, and it has no impact. My final part is to look at the D value, and I see that it's a negative 2, so that means it's going to go down 2 units. So this has just been, hey, how do I look at this and be able to pull out the information? All of the information is in this chart above. We've been building on it and building on it as we go from unit to unit. The hardest ones to remember, well, you got to just break it up. The A, the B information, the C information, and the D. 4 topics. Learn them all. Okay, now let's get into some applications. So in number 5, it gives me a red function and a blue function. And they're both labeled. I need to write out the domain. Okay, so instantly, f of x right here is equal to the red. Now, I know that it is a even radical. So I know that negative inputs aren't going to work. You also notice how it's touching 0? Well, 0 works. So my domain for f of x is going to be 0 to infinity. For h of x, I'm looking at it. I see the same type of dealio. I see a even radical, which means negative inputs are not going to work. However, notice how it's moved over to the right one? It's shifted right one. My domain is going to be shifted. Because of the x minus 1, it's going to have to be 1 to infinity. The reason for this is if I plugged in h of 0, that would be equal to 1/2 to the 4th radical of 0 minus 1. And this would simplify to be 1/2 to the 4th radical of a negative number, which would not work. Okay. List the transformations that were performed on the parent function to create h of x. Essentially, what happened? Well, my a is equal to 1/2. A half means it's going to be, since it's in the front, it's going to be a vertical compression. B, is there a number in front of the x? No, there is no b value. B is actually, there's an invisible 1, but that's not going to change it up. C, is going to be 1, and to shift to the right 1, and you can see that it affected the domain. And then finally, is there a D value? D value is currently 0 because it's no change up and down. The number 6 is very similar, but notice how in 6a it says it wants you to talk about the range. So looking at the graph, you can see that it's a scan from the bottom to the top. In f of x, essentially what's going to happen is that it starts at 0, and then it's going to get bigger and bigger and bigger. However, for h of x, you can see that it kind of stops at its limit. Its limit is at 3, and then it's going to go down to decreasing. So essentially what's happening is that the range, all of the negative numbers are going to work. It's going to go all the way from being a negative up to be 3, and it can be 3. Okay. List the transformations of that were performed on the parent function. Well, the negative in front is going to be my a value. It's a negative. If a negative by itself is -1, and this is going to be a reflection over the x-axis. Notice how it literally flipped from being here to be upside down. My b value is going to be 1/5. And since it's a fraction, it's the opposite of the a values. It's going to be a horizontal, and it's going to be a stretch. My c value is going to be nothing. At first, I want to say 3, but it is not part of the radical. My d value is going to be 3 up. And you can see what happened. F of x was flipped upside down, and then it was moved up. For number 7, the graph of the cube root is shown. On a coordinate plane, label a new function m of x, which is a translation 5 units to the right, 3 units up. 5 units to the right, 3 units up. I look at my key points. My key points is at 0, 0, 1, 1, -1, -1, -8, -2, and 8, 2. My goal is to move all these points 5 units to the right, and then 3 units up. 5 units to the right, 3 units up. 5 units to the right, 3 units up. And it will resemble let's call it m of x. Write the equation for m of x. Well, m of x is going to be equal to the cube root of x. I moved 5 units to the right. 5 units to the right, meaning that I moved 5 units. It's going to be -5. 3 units up, add 3. For the square root, notice how the domain only includes 0 to infinity. That's because negative inputs break the math. So I'm going to identify my nice points, and I see that I have a nice point here, I have a nice point here, I have a nice point here. I'm going to go ahead and reflect it over the x-axis and then translate it 4 units to the left. So I'm going to go ahead and make sure that my graph is the same distance from the x-axis. I see that this is 2 up, So then I'm going to go ahead and put a 2 up. And voila. So now, after I reflected over the x-axis, I now need to go 4 units to the left. Well, there's 1 at the origin. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And what did they want me to call this? A of x. So to write their equation for a of x, so I have to remember it's reflected over the x-axis. It's reflected over the x-axis. So the x-axis, right, is this guy. My value was up here, and it got moved over here, aka the y value became negative. Up at the top, it's positive. Over here on the bottom, it got flipped. So I need to affect the vertical component. This means that the a value has to be -1. The negative will be in front. So it's going to be negative square root of x. And then 4 units to the left means that it's going to be adding 4. Remember, to the left, it's always written as x minus -4. And this gets cleaned up to be this equation. So in 7 and 8, we basically practiced our skills further. We applied a transformation, and then we wrote out the new equation